Hey everybody, Jared from Abstract here, and in today's video, I'm going to show you how to create and deploy your own smart contracts onto Abstract using Hardhat. Let's jump right into it. So the first thing I'm going to do is open up the terminal here. And since I'm on a Windows machine, if you're on a Mac or on Linux, you don't need to worry about this. But if you're on Windows, we strongly recommend using WSL or WSL2. And if you don't already have that, you can simply run WSL-install. And since I've already got it installed, it's just going to swap on over to Ubuntu here, as you can see. Once inside the terminal environment, you'll also want to make sure that you have Node.js installed, at least version 18. So you can see here, just with a quick node-v, I've got v20 installed. You'll need at least 18 or higher to continue with this video. The first thing we're going to do is create a new directory. So we'll do mkdir my abstract project, and then we'll change directories into that newly created project. So we'll change directories into my abstract project. In my case, you can call it whatever you want. I'm going to use the Hardhat CLI to initialize a new project. To do that, we can run npm hardhat init. Of course, you can choose the preferences that you prefer from this setup process. For me, I'm a TypeScript man, so we will create a TypeScript project. We'll choose the root or the current directory that we're in for our project, and we'll add a git ignore, and we'll go ahead and install the required dependencies to do things like run the scripts and actually compile the smart contracts as well. Once that's done, you can just run a quick ls and see what actually got created. It should look something like this if it was successful. Great, so now we can go ahead and clean that up. And now we're going to install a couple of extra dependencies to work with Abstract. To do that, we're first going to run npm install -D, and this is going to install a couple of dev dependencies in our project. The first one that we'll add is @matterlabs/hardhat-zksync. And this includes a couple of packages within itself, actually. So @matterlabs has things like @hardhat-zksync deploy, verify, the actual compiler. So this is actually itself a collection of packages that will really just help our entire development flow from compilation to deployment to actually verifying the smart contract, and a couple of other helpful tools as well. And just for the purpose of this video, I'm going to do this on a new line so you can clearly see what dependencies we're installing here. The second one we're going to grab is @matterlabs/zksync contracts. Now this is useful if you want to interact with system contracts, which we should have another video about on our channel, depending on when you're watching this video. Essentially, this is useful if you want to run interactions with things like building your own paymaster or native account abstraction. If you want to create your own smart contract accounts, you can access the smart contracts themselves, as well as useful libraries to interact with, as well as interfaces to inherit the system contracts on Abstract. You can go ahead and install that to more easily access and build out smart contracts related to system contracts. The third and fourth dependencies that we're going to install is ethers and zksync ethers. So we'll do ethers, and you want to make sure you grab version 6 and zksync ethers again at version 6, and I'll go ahead and install all of these. So essentially, ethers is what we're going to use to actually interact with the smart contracts once we've deployed them, as well as actually deploy them and verify them within Hardhat scripts. zksync ethers is essentially an extension of ethers that has specific features for Abstract that we're going to utilize. Once your dependencies are installed, we're good to go, and you can open up the project inside your text editor. For me, that's VS Code. I just like to type code space dot to open it up in my directory here. Once we're inside, you'll notice we have a simple smart contract. We have ignition. I'm just going to go ahead and delete stuff that we're not going to talk about in this video. We won't cover ignition and we won't cover tests. We will obviously cover the smart contract itself, as well as the necessary configuration and compilation, deployment, and verification steps, which we will actually generate files for using the terminal. The first thing you'll notice is I have a big red squiggly line and my text is not all white, which if you're new to smart contract development, you can go ahead into the extensions and just search up for Solidity. The one that I have installed is here from Juan Blanco, and that enables things like the syntax highlighting and errors like this where it tells me I'm using the wrong version. So I'll just go ahead and change that to 0.8.24 to fix that little error there. So I'm just going to go ahead and delete all of the contents of this file, and I will rename this to hello abstract.sol. And firstly, I will do a simple license declaration just as a showcase. We'll use 0.8.24 in this video. We'll make a simple contract called hello abstract. And within that contract, we will write a simple say hello function that, as the name suggests, returns the string hello world. Now, what we want to do is actually compile our smart contract. So to do that, we're first going to jump into the Hardhat config here. So firstly, let's go ahead and install, import that @MatterLabs Hardhat zk-sync library on line number 3 here inside of our Hardhat configuration file. And just for those who are curious, remember, this is the first package that we installed during the terminal steps. And I mentioned that this actually includes multiple dependency packages. So you can see those here. For example, the node is for local development on a local node. This is the compiler. Obviously, this is for deploying and verifying and so on and so forth. So that's what we're importing here. We're basically saying to Hardhat, hey, here is a couple of configuration options that I want you to know about when we go ahead and write this configuration object here below all of the imports. So just as some background to those of you who are somewhat familiar with the Ethereum or EVM development process, when you write your smart contracts in Solidity, you're compiling them using a compiler called Solc, usually S-O-L-C, into bytecode. And the EVM understands bytecode because it kind of translates them to opcodes under the hood, which inform what instructions each of the functions and the constructor, essentially what the smart contract should do inside the EVM. Abstract has the same concept. You'll write your smart contracts in a high-level language such as Solidity, and you'll compile them into bytecode. But the compilation process is different, and the bytecode that actually gets generated is also different. So for this reason, instead of using Solc, we're going to use zk-solc, as we just imported as part of that Hardhat zk-sync package. So now within this config object, we can actually put an entry in here for zk-solc. And what we're going to do here is we're going to just set the version to latest. And optionally, if you plan to interact with system contracts, if you don't know what that means, you don't need to worry about this. But if you are going to interact with the contract deployer system contract or the nonce holder system contract, you will need to set this next flag to true. So here you can see we have a settings option, and one of these settings here is called isSystem, which actually is a deprecated name for enable error VM extensions. Basically, we need to set this to true if you are going to use system contracts like the contract deployer and the nonce holder. For most use cases, you can probably just safely set this to false. In our case, we're just deploying a simple contract, so we can set this to false. That's all we need to do to configure the compilation process. Now, while we're here, we're going to add some information about our deployment process. So what we can do is actually set up the abstract testnet as a network within this configuration object here, so that when we go to deploy and verify later, we have all of the fields that we need. You can, of course, grab the information for the testnet or the mainnet, depending on when you're watching the video, on our documentation at any time. Great. So to do that, all we need to do first is add an additional networks field into our config here. Within that, we'll add the abstract testnet network. And now we just need to populate the fields of the abstract testnet. So first, let's add the URL. So this is again available on the documentation. You can set the L1 network, which on the testnet is Sepolia. You then need to set zk-sync to true to tell it, hey, we're going to use the zk-solc compiler for this compilation, compilation for this network. And then for contract verification, again, this is on the documentation. You can paste in the URL to actually get your contract verified so you can view the source code from the block explorer here as well. One last final touch that you can also do is set the default network to be abstract testnet. Okay, so now we're actually ready to compile. So what we're going to do is jump back into the terminal here. We'll clean this up quickly. All we need to really do is run npx hardhat compile and then pass the network flag abstract testnet. And if we quickly jump into the VS Code while this happens in the background, you can see it's first downloading the actual compiler and starts generating the artifacts from the compilation process. I was too slow to show you that in real time, but if we take a look at VS Code now, you should see if this was successful, we now have two new folders, one of artifacts-zk and one of cache-zk. Now, if this didn't work for you, what I want you to try first is npx hardhat clean, which will kind of give you a fresh slate to compile from, and then just rerun the above command for compiling your smart contracts. Great, so now what I want to show you within the artifacts.zk directory, we can see underneath contracts, we find our hello abstract.sol directory, and here is a hello abstract.json file. Now this file looks kind of scary at first. There's a lot of stuff going on here, but this is kind of a lot of valuable information here. So you can see the contract name, the source name, which we'll use for verification later. It actually prints out the ABI for you. And if you've ever compiled Solidity smart contracts before, you've probably seen this. But what's interesting is the bytecode is different here. Different than what you would get if you compiled this for, let's say, Ethereum. Now, you don't need to know the details of everything that's going on here, but we are going to use this artifact to actually go ahead and deploy our smart contract in the next step. So now we have compiled our smart contracts. We're ready to deploy them to Abstract and actually verify those smart contracts as well. What I want you to do, if you haven't done already, is jump into the documentation and find the faucets section. So this is relevant if you've never used Abstract testnet before, or you have no funds on the Abstract testnet. You can get free testnet funds from an Abstract testnet or from one of the Ethereum Sepolia testnet faucets and bridge those across to Abstract. So option one is to use an L2 faucet directly and grab funds directly onto the Abstract testnet, or you can use one of the below L1 Sepolia faucets and bridge those across using either the native bridge or any of the third-party bridges listed in the documentation. So once you've actually gone ahead and gotten some testnet funds onto the Abstract testnet, you're ready to begin the next step. Next, what I'm going to do is export my wallet's private key. And importantly, you want to use a wallet that has no money associated with it. It should be a fresh wallet for your testing and development purposes. You're going to export the private key, which is a dangerous operation, and you should not use a real wallet with money or funds that you care about. So this is a fresh wallet that I have set up using the Coinbase wallet extension. So I'll go ahead and unlock this now. And here you can see, you can navigate into the settings. It will be different depending on what wallet you're using, but you can just Google MetaMask export private key or whatever extension or solution that you're using. I'll go ahead and copy the private key here from the extension. And then back within our terminal, what we're going to do is set up a Hardhat configuration variable. So instead of pasting our private key in plain text, which is vulnerable if you're planning on pushing your code somewhere like GitHub, we're going to set it using a configuration variable. So to do that, what we're going to do is npx hardhat, and the command is vars set, and the name of the key or the value that I'm going to put in here, I guess, for the variable is going to be called deployer underscore private underscore key. And this is going to ask us to input a value here. So that is obviously going to be the private key of the wallet that I just exported. And you can see this is stored somewhere else on your computer outside of the repository that you're working in. So it is a bit safer. Obviously, you still want to be very careful with the private key. And like I said, it's not recommended to use a wallet with any real funds associated with it for your development purposes. So now we've set up our wallet with some testnet funds. We've exported the private key. All we need to do now is write the script to actually deploy our smart contract. To do that, we can jump back into VS Code here. We can go ahead and close all of these. And in the root of the directory, what we're going to do is create a new folder called deploy. And within this deploy folder, we'll create a new script, deploy.ts or JS if you opted for the JavaScript setup. What we're going to do within this script is obviously deploy our smart contract. So step one is we're going to import a wallet object or a class, I believe this is, from the zk-sync ethers package. We'll then import the Hardhat runtime environment if you're using TypeScript. We'll then import the deployer class from Hardhat zk-sync. And finally, we'll import the vars, which is the configuration variables that we just set up for Hardhat. So this is going to be obviously used to import our private key into this script here. So then all we need to do is export a default async function and provide that Hardhat runtime environment as a parameter or an argument into that function here. Within the function, the first thing we'll do is just log out a simple running deploy script message. Then what we're gonna do is initialize our wallet by reading in the private key that we just set up using Hardhat configuration variables. So what we do here is set up a new variable called wallet. And this is a kind of confusing syntax, but essentially what we're saying is our variable called wallet is a new instance of this wallet class here. And this wallet class, as you can see, accepts a private key as the argument. So there, we're just going to read out the Hardhat configuration variable of our private key. So this is basically saying, hey, I want a new wallet, use the private key that I just provided using that configuration variable as the signer for that wallet here. So basically, this is the wallet we're going to deploy with. Once we have our wallet, we can then initialize a new deployer. So this is imported again from Hardhat ZK Sync. And the reason we do it this way is because deploying smart contracts is also a little bit different between Abstract and Ethereum, but that's a topic for another video. What we have here is we're saying, hey, here's my deployer. Again, similar syntax. This accepts the Hardhat runtime environment and the wallet that we just generated. So basically saying use the wallet to be the deployer. And then beneath that, we're going to actually begin loading in that smart contract. So you can see here, as I was mentioning earlier, these artifacts that get generated is what we're going to import to actually go ahead and deploy our smart contract. So really all we're saying here is, hey, read in the artifact of the smart contract called hello abstract, which if you remember was what we looked at here, which is hello abstract.json. So that's all we're doing here, saying, hey, here's all the details, the ABI, the bytecode that you need to actually go ahead and deploy it. Then what we're going to do is go ahead and actually deploy it. So we use that deployer object that we instantiated here to create a new smart contract by calling deploy. And all that requires is this artifact here. So we set up the artifact and we actually go ahead and deploy it. We store the result of that in this variable called token contract. It's obviously not a token in our case, it's just a hello abstract, but we can go ahead and fix that once we're done with the script. Once we actually deploy it, we're done. We just want to see if it succeeded, and if it did succeed, what is the address that it deployed to. So finally, we'll just add a little log at the bottom here. We'll say the name of the smart contract was deployed to, and get the address of the smart contract that was deployed. And we can go ahead and rename this to hello abstract contract and rename that here. Awesome. So now we've written our deploy script. Let's see how we can actually use this from the terminal. Jump back into the terminal, and here we're ready for the moment of truth to deploy our actual smart contract. So what we're going to do is run npx hardhat, and we'll use the deploy-zksync command. And what we're going to do is provide a script here. So we'll say -- script, and the script is the name of the script within the deploy folder that we created. So if you remember, we created /deploy as a folder, and then within that we created deploy.ts as the actual script name. So here we're just going to write deploy.ts and we'll hit enter. So this, as you can see, if you remember, we wrote that running deploy script log at the beginning, and looks like it was successful. It was successfully deployed to this address. So now what we can do is, using again the documentation here, we can go to block explorers and visit the abstract testnet explorer. And we can paste our smart contract address into the explorer. And what we should see is we have our contract here. And this was deployed by my wallet, at this transaction. The problem is, if we go to the contract, it's not verified. We can't see the source code of the smart contract. So if our users were to interact with this URL, they might not trust us in the smart contract code that we wrote. They might want to read it for themselves or even interact with it directly through the Explorer. So this is a pretty simple task to do. All we need to do is copy this smart contract address of the contract that we just deployed. I'll go ahead and clear this up. And we then need to run npx hardhat verify. And the kind of things that we need to provide to this verify script here is first the network. So we'll pass -- network abstract test net. And I'm going to run out of space here, so I'll do a quick little zoom out. But then the only thing we need to do now is just paste the smart contract address. So the smart contract address that you just deployed, copy the deployment address and paste it in here. And then we can go ahead and run this. And it says, oh, we've done a little typo on abstract testnet and give it the correct name, abstract testnet. And we should see your verification ID is as follows. And we were successfully able to verify our smart contract. So now if we revisit the contract on the block explorer here, if we give it a quick refresh, we should now see the name of our smart contract shows up, as well as if we visit the contract tab, you can actually see the contract source code here written in Solidity. We can also read and write the smart contract. Obviously, there's not much for us to do here, but we can, in theory, query what the say hello function says, and it returns hello world as you would expect. So users are now able to interact with your smart contract directly through the block explorer. So that's it for this video. Hopefully you were able to successfully get started with your smart contract journey on Abstract using Hardhat. Remember, if you have any questions or you got stuck at any point, there will be a link to a Discord channel where you can chat with myself as well as the rest of the team to answer any of the questions that you have inside of our dedicated dev channels within there. With that said, thank you very much for watching, and we'll see you in the next one.